We now descend into the technical and procedural heart of the organization, Tier 3, the Information Systems View. It is here, at the lowest tier of our hierarchy, where the theoretical meets the tangible. Every information system within an organization's portfolio exists within a specific phase of the System Development Lifecycle, or SDLC, whether it is currently operational, under active development, or undergoing significant modification. The SDLC is the foundational, multi-phase process used to plan, create, test, and deploy an information system. In Tier 3, risk management is not a peripheral activity or an add-on performed at the end of a project. Rather, risk management activities are integrated directly into the SDLC. These activities are designed to reflect the organization's overarching risk management strategy, while simultaneously accounting for the specific cost, schedule, and performance requirements of individual systems. As we discuss this, keep in mind that the outputs of risk management at each phase of the life cycle have a cascading effect on all subsequent phases. If we fail to identify a risk during the initial planning, that oversight will compound as the system moves toward deployment. While organizations may utilize various development methodologies, such as the linear waterfall model, the iterative spiral model, or the rapid incremental agile development approach, the requirement for risk integration remains constant. The process begins with the initiation phase. The most critical activity here is requirements definition. Information security requirements are a specialized subset of functional requirements. The specific behaviors, services, or functions a system must provide to satisfy its users. In this academic context, we must recognize that security requirements are not static. They are significantly influenced by the latest threat information available to the organization. A threat is any circumstance or event with the potential to adversely impact organizational operations. Our assumptions about these threats dictate the types of solutions we deem acceptable from both a technological and operational perspective. These requirements define two things. First, the security functionality, which is the set of security controls employed within or inherited by the system, and second, the trustworthiness of that functionality. We will define trustworthiness in greater detail in later lectures, but for now, consider it the degree of confidence we have that the system will behave as expected while resisting exploitation. As we transition into the development and acquisition phase, we enter the realm of system design, integration, and demonstration. This phase offers a unique opportunity for risk mitigation, the act of prioritizing, evaluating, and implementing the appropriate risk-reducing controls. By choosing design alternatives that are inherently less susceptible to known vulnerabilities, we can manage risk before a single line of production code is written. However, we must also confront supply chain risk. This refers to the potential for harm to an organization's mission resulting from a supplier's vulnerability or the subversion of a product's integrity. To address this, organizations must implement specific security controls during the acquisition process to ensure the components we buy are as secure as the ones we build. Furthermore, we must consider the environment of operation. A system designed for a secure, air-gapped facility requires a different control set than one intended for a mobile, cloud-based environment. To be effective, these controls must be mutually supporting. This means they work in concert rather than in isolation to create a robust defense in depth. When technical controls are limited by the inherent trustworthiness of the underlying technology, management utilizes compensating controls. These are alternate safeguards, often operational or management-based, employed in lieu of a standard control to provide an equivalent level of protection. Continuing our examination of Tier 3, we move from the drawing board to the actual deployment and eventual retirement of our information systems. Subsequent to initiation and development, we enter the implementation phase. This is a pivotal moment in the SDLC because it provides the organization with the first real opportunity to determine the effectiveness of the selected security controls. Before the commencement of actual operations, we conduct effectiveness assessments. We compare the expectations we generated during the design phase with the actual behavior of the system as it is implemented. If the assessment reveals that a control is not performing as intended, or if new threat information comes to light, we must be prepared to modify the implementation. In the professional world, this is where risk-related information is used to justify proposed changes to senior leadership. It is a process of validation. Does the system we built actually meet the security requirements we defined? Once a system is approved for operation, it moves into the operations and maintenance phase. This is typically the longest phase of the SDLC. Here, the focus shifts to ongoing monitoring. Monitoring is paramount to maintaining situational awareness, a continuous understanding of the risk posture of the organization's missions and business functions. We monitor not just the security controls themselves, but also any changes to the environment in which the system operates. This awareness is critical for making necessary course corrections when the risk level exceeds the organization's risk tolerance. If a new vulnerability is discovered in a production system, it is the monitoring process at Tier 3 that alerts the organization to take action. The final stage is the disposal phase. While it may seem simple, it is governed by standard procedures to ensure that any information that could cause an adverse impact is verifiably removed prior to the system's retirement. This involves assessing any risks associated with the disposal activities themselves, such as the physical destruction of drives or the secure wiping of cloud instances, to ensure no residual data remains. To conclude our look at Tier 3, we must address the why behind this integration. Early integration of security into the SDLC is the most cost-effective method for implementing a risk management strategy. When security is treated as an afterthought, it often requires expensive bolt-on solutions or disruptive late-stage re-engineering. To facilitate this, risk management must be incorporated into program, planning, and budgeting activities. This ensures that the necessary resources, personnel, tools, and time are available when needed to meet project milestones. This requires risk and information security professionals to be integral members of the teams addressing organizational requirements. Finally, we consider the concept of resilience. Resilience is a performance measure of how well a system operates while under stress. The wise use of technology during design and implementation is of paramount importance. If a technology introduces inherent vulnerabilities that cannot be mitigated, we may even have to re-engineer the underlying mission or business process at Tier 2. By making these requirements an integral part of the system's lifecycle, senior leaders ensure they are taking appropriate actions to exercise the organization's due diligence. They are not just checking boxes. They are actively managing the risks to the mission, the assets, the individuals involved, and ultimately, the nation.